we're going to solve a trig equation. Here it is. Solve this. Cosine of 2 theta equals cosine of theta. Now if we had a calculator, we certainly could just graph this. Graph the left side and graph the right side, figure out where they intersect. We're going to graph this, solve this by hand. Okay, so I first notice that we have an identity here, cosine of 2 theta. And that identity is one of the double angle identities. So I have a couple choices with that. Sometimes it's hard to know which one to choose. I got cosine squared of theta minus sine squared of theta. I have 1 minus 2 sine squared of theta, and 2 cosine squared of theta minus 1. But I'm going to choose this one. And the reason I'm going to choose that one is because we have the right side that's already cosine. All right, so I'm going to go back to this, and I need to remember that this is 2 cosine squared of theta minus 1. So 2 cosine squared of theta minus 1 is the same thing as cosine of 2 theta. All right, so now I'm going to get everything to one side. Okay, so to do that, I got 2 cosine squared of theta. I'm going to bring this over, subtract cosine of theta, and I got minus 1 equals 0. We like to get everything equal to 0 because then we can try to factor. Okay, so I'm going to try to factor. I got 2 cosine of theta times cosine of theta would be 2 cosine squared of theta. To get to negative 1, I have a 1 and a 1. Now I need to know which of these ones is negative. Okay, so if I multiply 2 cosine of theta times 1, that'll be 2 cosine of theta. And then I have 1 cosine of theta. So I really want the 2 cosine of theta negative. Therefore, this is going to be negative, and this is going to be positive. If I distribute that out, that would turn out to be this. Okay, now I can solve because 2 cosine of theta plus 1 equals 0, and I can also say cosine of theta minus 1 equals 0. So I really have two different solving equations. This turns out to be cosine of theta equals negative 1/2, and this is cosine of theta equals 1. Okay, so let's look first at cosine of theta equals negative 1/2. Well, I know cosine is negative in quadrants 2 and 4, so I'm just going to draw this out. I know I have a possible angle in 2, at 2 and 3 I should have said. Okay, because now I got negative 1 over 2 and negative 1 over 2. So this is going to end up being square root of 3 and negative square root of 3. Using Pythagorean theorem, these are right triangles. So this means that I have a 30, 60, 90 triangle. So I know that this is 60 here. So if I look at this angle, that's got to be 120. And if I look at this angle, that's going to be 180 to there, and then 60 more, so 240. So theta could be 120 degrees, or theta could be 240 degrees. Now, the thing about this is that it could be any multiple of this as well. It could be any multiple after 120. So every 120 plus 360k, and 240 plus 360k, where k is just an element of the integers. So negative 3, negative 2, negative 1, 0, 1, and so on. All right, let's take a peek at this one. Where is cosine 1? Well, cosine is the x value. Where is the x value 1? Well, it turns out, if we're looking at the unit circle, this is 1 right here, right at the 0 point. So theta is 0 degrees, or any multiple of 360 after that. So we add 360k to that one as well. If we are just finding the answers from 0 all the way up to 360, we just have 0, 120, and 240 for our complete answer of this problem. All right, so solving this problem, we substituted in using the identity, we factored, split it using the zero product property, and used the knowledge that we've gained throughout the course to get our answers of 120, 240, and 0.